Okay, so this problem is asking us to consider this differential equation. Let y equals f of x be the particular solution that goes through 1 comma 0. And then it asks us to write an equation for the line that is tangent to the graph at the point 1 comma 0. Use the tangent line to approximate f of 1.2. Okay, so for part A, since the derivative is equal to e to the y 3x squared minus 6x, if I wish to find the equation of a tangent line, I need the slope and the point that is on the particular tangent line. We're actually told what the point is, so we'll use the point 1 comma 0, and to figure out the slope, we will use the derivative. So I'm going to take the dy dx and I'm going to evaluate this at the point 1 comma 0. So at 1 comma 0, the y coordinate is 0, so that's e to the 0. And the x coordinate is 1, so that's 3 times 1 squared minus 6 times 1, which of course is 1 times, say 3 minus 6 is negative 3, which is equal to negative 3. So our slope is negative 3. So therefore the solution to the problem is that the tangent line would be y minus 0 equals negative 3 times x minus 1. Now that's sufficient for finding the equation of a tangent line, but it does ask us to use this. So I'm going to write this a little bit easier from negative 3x, just do a little bit of distributive property so that I can use this to approximate f of 1.2. So f of 1.2 would be approximately equal to the tangent line evaluated at 1.2. So that would be negative 3 times 1.2 plus 3, which is negative 3.6 plus 3, which is equal to negative 0.6. So that seems to be the answer to the second part of the problem, which is approximating f of 1.2. Okie doke. So now part B. This problem asks us to find the particular solution to the differential equation that goes through 1 comma 0. So for part B, we'll take the differential equation provided, dy dx equals e to the y 3x squared minus 6x, and we'll separate the variables. So I will multiply both sides by e to the negative y, which will create an e to the negative y dy over here, and I'll multiply over by the dx to create 3x squared minus 6x dx, and then I will perform an integral. So on the left-hand side, when we antiderive, the antiderivative of e to the negative y is e to the negative y with a negative sign by the substitution rule. And the antiderivative of 3x squared is x cubed. And the antiderivative of 6x is 3x squared. And there's our constant, so that way we can use this to figure out the 1 comma 0. What is the constant equal to with this fixed condition at 1 comma 0? So here the y would be equal to 0, so negative e to the negative 0 would be equal to 1 cubed minus 3 times 1 squared plus a constant. So negative 1 equals 1 minus 3 plus c. Negative 1 equals negative 2 plus c, and adding 2 to both sides means that 1 equals c. So the actual solution is now negative e to the negative y equals x cubed minus 3x squared plus 1. But the problem does specifically say that they wish for it to be y equals f of x. So the last thing I'll do here is actually solve for the y. So multiplying through by negative 1 yields negative x cubed plus 3x squared minus 1. Taking a logarithm yields negative y equals ln of negative x cubed plus 3x squared minus 1. And multiplying by the negative 1 yields y, which we'll call f of x, to be negative ln negative x cubed plus 3x squared minus 1. And that should be our final solution.